Hello all, good evening. Welcome for the next session. Uh, 150 must do questions. So we have been taking these sessions and this is the third segment of the same. So I hope you have been there in the first few sessions. The idea is to bring forward problems uh, which are, you can say, often tested concepts, most expected problems, uh, new problems, new style of questions, because CAT is always known for its game. Its game of challenging you with concepts which perhaps you have never uh, seen before, right? So I hope all of us are in line with the 100 days to CAT that is there in front of us, and so this is the time that we should be looking at a mixed bag of problems, right? The expectation is that we have a bit of good enough knowledge of all the concepts, I mean all the topics, and now we're looking at these questions, uh, you know to apply what we have learned so far. Okay, so here we go, people. Let's start with the session. 150 must do questions, part 3. All right. Yeah, so before we start, just a quick reminder, if you're not aware, that Career Launcher is out with its mobile app, and something that you can make full use of, learn while you travel, and it's available on both iOS as well as Android. So one of the many things that we have to offer, right? So something on your device, something that can help you, our app is out. All right, now, so yes, people, are we ready? Are we ready? Right? Let's solve together. So let's see. Here we go. Question 1, ratios. So I'm reading this out, and I hope you're solving along with me. And if you're getting the answer, do let me know. If there are any queries, do let me know. I'll be responding to everything in live, right? So Ketan intends to distribute 319 marbles among Purab, Rahim, and Tarun, such that 15 times Purab's share equals 16 times Rahim's share, which also equals 18 times Tarun's share. But mistakenly, he distributes them in the ratio of 8 is to 6 is to 5, respectively. How many marbles did Purab get as compared to what he should have got? So, some mistake has happened. We have to check out the delta, the gap between the actual value and the expected value, or the value that should have been there. Okay, so how do we do this? So the thing is that here the ratios are presented in two different ways, whereas the second ratio, the ratio which was the intended one, I mean sorry, the ratio in which he actually distributed is given directly, but the first ratio is actually given in a kind of a three-way equality form. So if I denote P, R, and T as the respective number of marbles that Ketan had intended, so we have this equality that 15 into P equals 16 into R equals 18 into T. So from this three-way equality, how do you get the ratio of the number of marbles and how you get the actual number of marbles? So the most convenient way to deal with this situation is, with this three-way equality, is to equate this quantity so so that a, the number is a multiple of all these values, because all these three expressions are equal, so they must be a multiple of 15 as well as of 16 as well as of 18. So can I say we are looking for a common multiple or a LCM of 15, 16, and 18 to write over here, so that we can then figure out the ratio between the quantities, right? So what is the LCM of 15, 16, and 18? Now let's think on that. 16 is only 2 power 4. 18 has a 9 in it. So I need to multiply 16 with 9 and that becomes 144. There is a 5 in 15, so 144 needs to be multiplied with 5. So 144 into 5 is 720. So a number which is a multiple of all the three is a multiple of 720. That's the LCM of these. So can I say if all these three numbers are equal, they are equal to a multiple of 720. So let's say that this is equal to 720k. K is our unknown constant, which we will now figure out from 399. So if 15p equals 720k, then what is p? 720 by 15, what is that? So 15 fours are 60, and then 12 120, 15 into 8, so this is 48k. So now I'm getting the ratios, right, by dividing. So what is r? 720 by 16, so 16 into 4 is 64, and then 8 80, so this is 45, so this is 45k. So p ratio r is 48 ratio 45. And likewise t, 720 by 18, 18 into 4, so this is 40k. So the ratio between the three is 48 is to 45 is to 40. Hence, what is the total? The total is 48k, 45k, and 40k. That is 133k. So 133k is equal to 399. So our k therefore is 3. So remember, these values are the intended values. This is not the actual. This is what was supposed to be. So Purab, what he should have got. Purab, what he should have got. Right. This is that quantity. So that is what Purab should have got 48k, and k is 3. So this is 48 into 3 or 144. So this is just one part of the problem. Now comes the second part. So in the first part, we deciphered the ratio from the three-way equality. So the trick is to equate it to the LCM of the numbers, and then you get the ratio. That's the part. That's the point. Now coming to the second point, 8 is to 6 is to 5. So it's direct ratio. So can I say 8x, 6x, 5x? This is the actual values, what Ketan actually distributed, right? So the sum of these three based on the ratio should be again 399, right? So what do we get? 8 and 6 is 14, 14 and 5 is 19. So 19x is 399. So x is coming to be 21, 399 by 19, right? 19 to the 38, and then again 119, so 21. So what Purab actually got, right? The Purab's actual number is therefore Purab got 8 ratio, so 8x. So he got 8x or 8 into 21, which is 168. So what is the difference? He got more. He actually got more than what he should have got. So the answer is more. And how much more? 168 minus 144, which is 24. He got 24 more than what he should have got. So a basic question I would say, you should know this, how to figure out the ratio between three quantities from a three-way equality. Right? That was the key point. Otherwise, the second part was very direct. Ratio was given, and then you looked at the difference. Right? Direct questions have been asked on ratios very frequently, even in recent years. Right? So the ratios is one of the core concepts on arithmetic. All right. Now here we go. Next one, people. Buck up, buck up. I'm looking for seeing your response, people. Yes, you can do this. Profit, loss, and discount. Okay, so let me know if you're able to do this. Let me take this up now. So the idea on this question is basically how to figure out the overall profit and loss, right? When it is divided into different fragments, right? That's the point of this problem. To attract customers, a retailer sells an item 10% below its cost on the first day. One more thing you will see in this question. You'll not see any numerical, any monetary value in this question. You're not seeing any rupee, dollar term. You're just seeing percentages, and percentages asked. So whenever you see a question in which no numbers are there, no monetary terms, no rupee 100, nothing is there, the key is you can make any assumption. When it is not given, then whatever you assume will never impact the final answer, right? To attract customers, a retailer sells an item 10% below its cost on the first day. It means he bears a 10% loss on the first day. On the second day, he marks up the goods by 60% and then offers a 12.5% discount on that retail price. Right. So first day he does his slow business. He to attract the customers, he offers a low price. Then on the second day, he actually comes into his, uh, you know, uh, profit making mood. Right. He marks it up. He marks up and then he offers a slight discount as well to lure the customers. The typical way. If the retailer sells thrice as many items on the second day as against the first, how much percentage of profit does he make on the total sales? Okay. What is the cost of the goods? Not known, right? How many actual number of uh, goods he sold on the first and the second day? Not known. However, the ratio is known, minus to 3. So if ratio is known, that is also sufficient. So you can take the simplest numbers. You can start by assuming the cost of, let's say, one item as the simplest number, 100, and just start with that, right? So make our assumption. Let's say the cost of the goods is 100 rupee per item, right? I don't know what item it is, that even that I don't know, right? And also let's assume that he just sold one item on day one, that's all, and three items on day three, on day two, right? It really does not matter whether it is 1 versus 3 or 100 versus 300 or 2 versus 6. That really does not matter, right? So therefore we are making our two assumptions. Cost is 100 rupees and he sold just one item on day one and three items on day two. What is the total cost of the goods he sold respectively on the 2 days? On day one, he just sold one item which cost 100 rupees. So it cost him 100 rupees. On day two, he sold three items for 100 rupees. 3 into 100, 300 is what was his cost on day two. What is his total selling price or revenue on the 2 days? On day one, he bore a 10% loss. So 100 he sold for 90 rupees. Okay, ABX something something, option D. Very nice, very nice. Thank you. Yeah, good people. Right. So 90 rupees is what he earned on day one. On day two, what did he earn? So what is the selling price? First of all, write the per item selling price. Right. First, he marked up by 60%. So that came to 160 rupees. Mark price. Let me write this as the marked price. This is the marked price. 160 rupees, 60% above 100. Then what is the final selling price? So you need to decrease this by 12.5% or 1/8, right? So selling price, can I say, is 7/8 of the marked price, because it's 12.5% less or 1/8 less. So it is 7/8 of the marked price, which is very simple. 140, 7 by 8 into 160 is 140. So what is the total selling price? 3 times 140 or 420. Now let's compare the total selling price and the total cost. What is the overall total cost? 100 and 300, 400. And what is the total revenue? What is the total selling price? 90 here and 420 here. So that would be coming to 90 and 420, 510. So what is the profit? On 400, he earned effectively 510. So the profit is 110 rupees. So what is the profit percentage? Because we don't want the profit percentage. So profit percentage is profit over cost, right? So profit is 110 and cost is 400. So 110 on 400 into 100% is your profit percent. This is 11 by 40 into 100. Yeah. So 11 by 4 would be 2.75. So this is coming to be, finally adjusting for the decimals. Yes, B option, 27 and a half. Right. Thank you, Scale Up Stories. Thank you, ABXH something something. Right. Uh, nice. Right. Good participation. All right. So good. All of us are alert, aware of the things. Now, if you are aware of this, stay tuned for some very interesting questions coming your way. All right. Let's see. Here we go. Third one. Mixtures and alligation. I'll pause for a minute for you to take this problem, understand it, and try it out before I start speaking. So I'll just give you a minute. All right. Okay. So keep trying, and if you get this, let me know. Now, I've so this question is a very this question has the idea behind it, which is called removal and replacement. So if you have followed our sessions and if you have done this before, so I'm using that concept directly in. So the process of removal and replacement is that you remove a certain part of the solution and you replace it with one of the two things. So there's a mixture. So that is exactly what is happening. 10% bottle is emptied and replaced by milk. Ratio becomes 4:1. So whatever you're pouring in back in the solution, that is obviously increasing in percentage. So you're pouring in back milk, right? In the first instance, replaced by milk. So you're diluting the water. The percentage of water will go down, obviously. So the removal and replacement, the concept on that is that whichever thing out of the two things you're diluting, the fraction or the percentage or the proportion of the thing which is being diluted, the final fraction of that is equal to its initial fraction. F final is F initial into 1 minus the fraction of the solution removed and replaced. In simple terms, what this means is the thing which you're diluting, the percentage of that decreases by as much proportion as is the proportion of solution that you have removed and replaced. I can explain this in one more line. When you removed 10% of the solution, you had removed 10% of the water also. When you poured milk back in, you restored the volume back to its initial state. Hence, the water content decreased by 10%, whereas the volume remains the same. Hence, obviously, the percentage of water would go down by that 10%. Simple, makes sense, right? Yes, Avinash. Yes, multiplication factor, right? Okay, right. So, do you get that logic, right? So, in the first instance, from that 4:1 ratio, I will work on the fraction of water, right? And I know the final fraction of water, I will be able to backtrack the initial fraction of water, right? So since we are pouring back milk in the first instance, so we will say that the final fraction of water is its initial fraction, right, into 1 minus the fraction of solution removed and replaced. I'm writing this small v by capital V, which denotes small v is the part of the solution removed, capital V is the total volume of the solution, right? So this fraction is 10%. So we know the final fraction of the water is simply 1/5. 4:1 is the ratio. So it's a water which is 1 out of 5 parts, right? So 1/5 equals the initial fraction which we are trying to find into what? 9 by 10, right? 1 minus 1/10. So from here, we can get that the initial fraction, therefore, of water is coming to be 1 by 5 into this goes over there 10 by 9. 5 cancels, so this is simplifying as 2 by 9. So the initial solution had the milk to water as 9:2. Water was 2 parts, milk was 9 parts. Now, right? So milk to water initial was 9:2. Sorry, my bad. Sorry. This is fraction. This is fraction. So out of 9 parts, 2 parts are water, 7 parts are milk. So the ratio was 7:2. Right? From fraction, how do you get the ratio? Like this: 7:2. 2/9 is the water. So 7/9, the remaining is the milk. So 7:2 is the ratio. So milk is 7/9. Now the question is going into the if then hypothetical situation. If this happened, then what would happen? If after emptying 10% bottle, it was instead replaced by water, what would have been the ratio of milk to water? So now since we are pouring back water and not milk, so the milk is being diluted. So we'll apply the formula on the concentration of milk. So now we know that the initial fraction over here of milk is 7/9. So from this next process of removing and replacing with water, the final fraction therefore of milk will be its initial fraction, which is 7/9, into 1 minus 1/10. Its concentration will decrease by 1/10. So this is 7/9 times 9/10, or simply 7/10. So it's 7/10 or 70% milk. So therefore 70% milk, remaining 30% water. That would be the situation, which is a ratio of 7:3. 70%, 30%, 7:3. Isn't it? So a lot of backtracking and a lot of careful application of this concept of removal and replacement. Right? I explained that also, and this is how we can do this. Right? Time and work. Time and work. Yes, yes, yes. So now again, very interesting problem here. Something new, something a very unusual kind of a problem that we have. Everything is in percentage, nothing about number of days taken to do the work, nothing like that. Right? So I'll again give you a minute because this is a very interesting problem. So just give a thought on this, think through, and then we'll discuss. All right. So I hope you had some thought on that. I'm still waiting for your answers. Let me know if you're getting this. Now, what's the deal over here? Now, you saw a question earlier on profit and loss where we did it by assuming some numbers. So here also, that's the point. Nothing is given as such, nothing about number of days required, nothing about the work. So you can assume anything. You can assume the total work, let's say, all right? What is the objective? You have to find if both work together, each one at the usual efficiency, what fraction of the work shall be done by Anaya. So basically, when two people are working together, then the work is being shared in the proportion of their efficiency. Like if I'm working, if my efficiency is twice of your efficiency, so I will be able to do 2/3 of the work and you will be able to do the remaining 1/3, because 2:1 is the ratio in which will be sharing the work if my efficiency is twice of u. So basically the objective of the question you have to understand is to establish the relation, which is the ratio between the efficiencies of Anaya and Bhavin, right? Now, so now the key to this problem is to decode this statement and then conclude upon that ratio of efficiencies. Uh, let me define that the work that these two people are doing, Anaya and Bhavin, is, let's say, 100 units, right? Whatever that nature of the work is, we don't know. Let's just say it's 100 work units, right? So Anaya can do therefore 75 units of the work at 90% of her efficiency. So therefore now let's define two variables, A and B, for the respective efficiencies of Anaya and Bhavin. Let's say I'm assuming I'm taking two variables to define the efficiency, which means the basically the work rate, the rate at which the two people are able to do the job, right? So Anaya can do 75% of the work at 90% of her usual efficiency, right? So 90% of A, 90% of her usual efficiency, she's able to do 75% of the job, right? Right. So 90% of A equals 75 units, isn't it? She's able to do 75% of the work at 90% of her efficiency. So 90% of A equals the 75 units of work that she's able to do. Whereas for Bhavin, we can similarly write that he can do 40% of the work. So he can do 40 units at 80% of the efficiency. So 80% of Bhavin's rate is 40 units of work output, right? Simple. This is what you had to decode, or this is what you had to establish, which will now give us the relationship between the uh, rates of the two people. That's all. You assume the total work 100, right? It is given that in the same time they're able to do this work. So, right, so therefore we can say that if 100 is the work, they are able to do 75 and 40 units of the work in the same time at this much percentage of their usual efficiency, right? So simply divide these two equations. Now you will get the ratio of A's to B, right? This is first equation, this is second equation, and dividing them, you can say 90% of A, so 90 into A upon 80% of B, so 80 into B, or simply 9 by 8 times of A by B is 75 by 40, which is 15 into 5. Sorry, 5 can be cancelled. So yeah, 15 into 5 and 8 into 5, 15 by 8. So therefore your A by B is coming to be 15 by 8, and this 8 by 9 can come over here. 8 cancels, this is 15 by 9, or simply 5 by 3. So that's the ratio, 5 is to 3. And therefore 5/8 is what Anaya is able to do, right? 5 is to 3 is the ratio. So out of the total 5 plus 3, 8 units of work that they will be able to do at their usual efficiency. So now they're working at the actual efficiencies of A and B. So 5 plus 3, 8 out of total of 8 units, 5 units done by Anaya. So 5/8 of the work can be done by Anaya, right? So the thing is, I think the the crux of the matter is, when nothing is, no numerical values are given, you can make an assumption and start with that, right? I started by taking 100 units for the total work, and then I wrote the equations for the work done. All right. So the theme is, I like this, डर के आगे जीत है, right? You might get scared. Oh, I am not given any data, what to do? So that is what I'm trying to establish. How can you do the things, when the numbers are not there, right? Make your assumption, start with that, get it done. All right. Okay. So it's a mixed bag, geometry, circle. And the figure is there in front of you. Again, I'll pause for a minute. I'll let you just look at this, and I'll allow you to use your any kind of calculators also. This question requires little bit of calculation part. Circles is one of the uh, you know uh, something that comes quite often, and very interesting questions are asked on circles. Okay, so I'm let me know if you're getting this. So how do you do this? Okay, yeah, so the figure is already there. You can see there is a circle inscribed inside of a quarter circle. That's what it is, right? The proportion of the area of the quarter circle you have to find as covered by the circle, right? Means the circle is what percentage of the quarter circle in terms of its area, right? What proportion is covered by the circle. So obviously you have to establish the relation between the radii of the two things. Both are circles. Effectively there is one a circle with on, but only 1/4 of it has been drawn actually. I mean, the original figure would have looked something like this. I could draw the full circle, and then I can say, okay, I have divided this like this, and then I have drawn a circle over here. Effectively that's the story, right? I've drawn a circle inside a quarter circle. So, but I'm just focusing on that quarter circle exclusively, right? So what's the story? Effectively, these are two circles touching each other internally. What is the base concept around that? When two circles are touching internally, the most basic concept is, let's say this is one circle, this is the other one. So they'll be touching at some point. Obviously, that's why they are like that. So whatever are the centers of these two respective circles, like this and this, if you join them, then that line joining the centers is always collinear with the point of contact. C1 the center of the larger circle, C2 the center of the smaller circle, and P the point of contact. C1 C2 P is a straight line, they are collinear. That's the core idea on this. So therefore you need to apply that over here, right? This, my dear friends, is the center of the circle, and this, my dear friends, is the center of the quarter circle, this point B over here. And this, my dear friends, is the point of contact of the two circles. These 3 points are collinear. So therefore, you can join them, and that's a straight line. And that straight line taken all together from point B to point P is the radius of the quarter circle. Now you have to decode the radius of the circle, the smaller part. From this point O, the center of the circle, to the point P is obviously the radius small r of the circle. From this point O, you can see this point of tangency. Join this center to this point of tangency. You know that the radial line is always perpendicular to the tangent at the point of contact. Likewise, this is also the point of contact of the tangent over here. This is also 90°. Let's say this is M, let's say this is N. This angle B is obviously 90°. Yes, CAT exams, thank you, correct. You got that. Good, good, yeah, perfect. Right, so this O, so the point is obviously now this OM is the radius small r, this ON is the radius small r of the circle. Obviously this ONBM is a square. Obviously this ONBM is a square. And therefore that OB line is the diagonal of that square, which therefore becomes root 2r. So now have you not identified that BP, which is the radius capital R of the quarter circle, is therefore BO plus OP, which is root 2r plus r. So you establish the ratio which you needed, that the larger radius is root 2 plus 1 times the smaller radius. So hence the calculation that we need to do is pi r square, the area of the circle, is what fraction of the area of the quarter circle, which is quarter circle, 1/4 of the area of the circle. So 1/4 of pi r square, capital R for the larger radius. So this is a ratio. This is the fraction. So pi upon pi by 4, pi cancels, 4 comes on the top. So this is 4 r square by r square. In fraction terms, this is this. You can do into 100%. So I let this calculation for you. I mean, from here you can say, we say that small r is basically capital R over root 2 plus 1. When you rationalize 1 over root 2 plus 1, you simply get root 2 minus 1, right? So the smaller radius is root 2 minus 1 times the capital radius. So small r by capital R is basically root 2 minus 1 after rationalization, and hence the required fraction is 4 into r by r, which is root 2 minus 1 the whole square. So when you calculate this in decimal, you get approximately 0.69, right? So therefore that's what it is. Okay, all right. So concept was the touching circles touching each other internally, that the line joining the centers is collinear with the point of contact. Hence you can so typically in geometry you're doing your extensions, you're connecting things, so you had to do this connection, you had to drop the altitudes to the tangents, you had to connect the radial lines, and then had to analyze the geometry. All right, people, interesting, even more interesting, geometric counting. Now, so I'll again give you a minute. It's a theta question, so you have to give the answer without any options. To help you, using the vertices marked on a rectangle as shown below, you can see the vertices on the rectangle. You have to count them. How many triangles can be drawn? Right? It's a question of PNC in in the setup of a geometry problem, right? Geometric counting. How many triangles can be drawn using these points? Okay, so let's see who can do this first. I'm starting. Okay, now how many points do you see? Right, 5 points here, 5 points here, 10 points, two more here, two more here. So total of 14 points in total, right? 5, 5, 10, 2, 2, 14. All right. Uh, right. Keep on trying. Not correct this time. Uh, right. But keep on trying. Okay. So, CAT exams, I think what you're doing is you're doing direct counting. I think. Because your answer is way below the correct answer. So see what I have deliberately put this question. Very clear intention is there. Whenever you have a counting question, how many of something, always think through, always analyze. Is the direct counting easy to do? Or is it too complicated, too many cases, too many possibilities? If that is the case, then you should do the complementary counting approach, which is all the total things possible minus the non-favorable things. If you've tried to do the direct counting, which is how many triangles can be drawn, so trying to figure out from where do I pick one point, from where do I pick the second point, lot of cases. You can have 2 points from here and the third point from anywhere else over here. You can have 1 point from here. You can have then 1 point from somewhere here, 1 point from somewhere here. So you can do a mix and match as that the three vertices are on three different sides. You can also have, you will have different cases based on whether those 3 points are within inside of the edges or are they end points of the square. That will form different cases. Too much complexity with direct counting. I hope you would appreciate this, that it is really tedious task to do the direct counting because the cases are too complicated to analyze. So therefore, what you should be doing is you should be just saying, I have a total of 14 points. A triangle is formed when I select any 3 points from them. But all the 14 C3 combinations of selecting the three triangles, of selecting the 3 points will not always form a triangle. So now you're doing the complementary counting approach, which is much easier in this case because there are only 4 edges and there are only 4 ways to select 3 points from a group of collinear points. So you can now easily subtract those 4 situations, those 4 cases when all the 3 points are selected from any one of the sides. There are 5 points on 2 of the edges. So 5C3 plus 5C3, let's call this A, B, C, D. So 5C3 is for AB edge, 5C3 is for selecting any 3 points from the edge AB, 5C3 again is for selecting any 3 points from the edge CD, and there are a total of 4 points on the other 2 edges you can see. So plus 4C3 plus 4C3 respectively for the edges AD and BC for selecting a group of collinear points. That is your answer. CAT exams, your calculation is still not correct. And this is the answer which you can calculate and finish off. That will be your answer. 14C3 will be 14 into 13 into 12 by 3 factorial, which is 6. Right? That is how you do NCR calculation. 6 cancels. This is 2. So this is 14 into 13, which is 14 into 26. Let me just write it like this: 14 into 26 minus. This is 5C3 is 10. So 10 plus 10 and 4C3 is 4. So plus 4 plus 4. So this is overall 28. I can see 28 can be factored from here also. So let me write this 14 into 26 as rather 28 into 13. That is easier, so that now I can say this is minus 28 and effectively this becomes 28 into 12. That is your correct choice, or that is your final answer. 28 into 12 means 28 into 10, 280 plus 28 into 256, 280 plus 56. Finally your answer is 336. That is the number of triangles. All right, so what's the moral? Think through, is the direct counting easy or is it way too complicated? Should I do the complementary counting approach if the direct counting, the cases are too complicated? All right, all right. Yes. So bringing forward all these concepts, people, which are highly relevant. Here comes the next one. Okay, so something hardcore on algebra over here, along with some basic idea of probability being used over there. Let A, capital A, equal to curly braces 2, 4, 6, 8, 10. This is the standard notation of a set. So two sets are given. Let set A equals this group of 5 numbers 2, 4, 6, 8, 10, and set B equals 1, 3, 5, 7, 9. Consider a function fx equals x squared plus ax plus b, a simple quadratic function with coefficient of x squared as 1 and then ax plus b. Very nice. I'm taking that. A and B are randomly selected from the sets A and B respectively. So basically A, the variable A can take these 5 numbers 2, 4, 6, 8, 10. and the variable b can take these 5 numbers 1 3 5 7 9, and that is how this function will be defined. So a has 5 choices. The choice of each of the variables are 5 choices, a and b each. What is the probability that fx is more than 0 for all real values of x? Now this is the core thing to analyze. When will it happen that this quadratic function will always be positive for all real values of x? When does that happen? We all know that a quadratic function, the graph of that is a parabola. Particularly when the coefficient of x square is positive, which is there in this case, it is an upward facing parabola. It is going upward. A parabola can have two distinct roots. In that case, it will be intersecting the x-axis at 2 points. Now, in this case, the function fx is not positive for all real values of x because between the roots, it is going negative. Or the quadratic function could be touching the x-axis at one point, in which case also it is not always more than 0 for all real values of x, because when it touches the x-axis, it becomes equal to 0. This case of two roots is when the discriminant is positive. This case of touching the x-axis is when discriminant is 0. So we are not looking for these cases. We are looking for that case when this function is always more than 0, which means it is never intersecting the or even touching the x-axis. It is always staying above the x-axis. In other words, there are no roots. There are no roots, which means your discriminant is negative. So basically, you have to first interpret, you have to first understand that my discriminant is negative for this quadratic function. So we have to find the probability that the discriminant is negative for this quadratic function. So probability is defined as favorable cases or favorable number of ways upon total number of cases or total number of ways. So the cases are here with respect to the combination of the pairs of values of a and b that can be selected, right? How many pairs of a and b are possible, which are favorable such that fx is always more than 0, and how many total ways we can select those pairs. So what is the total number of ways? What is the total number of ways to select the pair of variables a and b? Obviously, you're doing two selections, first for a and then for b, each of which have 5 choices. So 5 into 5, total 25 ways are there to do that selection. So 25 is your denominator. Now for the favorable ways, discriminant should be negative. This is the condition. So discriminant in this case would be what? It is b square minus 4ac. But be very careful. I'm not saying in respect of these variables. I'm saying in respect of whenever coefficients are set up such that ax square plus bx plus c is fx, then b square minus 4ac. But here it is quotient of x square is not a, rather quotient of x is a. So what does the discriminant become? A square, where a is the quotient of x, right? Minus 4 into this. So 4 into 1 into b. So minus 4b. So this is your discriminant, right? And this should be negative. Or in other words, if I take 4b over there, so 4b should be more than a square, or you can say that b is more than a square by 4, or simply a by 2 whole square. Now you can make your cases based on this condition to be satisfied, because once you assume the values of a, then the respective values of b, we can figure out the different combinations, right? CAT exams have got this question. Yes, correct answer. So when a is 1, what values can b take? So b should be more than a will take the values of 2 4 6 8 10. So when a takes the value of 2, so b has to be more than a by 2 whole square, or 1 square 1. So b is more than 1, which means that b can be taking the values which is 3 5 7 9. So these are four cases which are favorable. When a is 4, then b has to be more than, as per this condition, 4 by 2 whole square, which is simply 4. 4 by 2, which is 2 square, 4. B is more than 4. So B can be taking not the values of 1 or 3, but 5 and onwards. So we can take the values of 5, 7, 9. So 3 cases we have favorable. When A is 6, then what can values can B take? B should be more than what? 6 by 2, 3 square, 9. But there is no value of B which can be more than 9. So no further cases will be favorable to us, because further the constraints will be even beyond the limit, right? When A is 8, for example, B has to be more than what? 4, 8 by 2, 4 square, 16. Not possible. So only 4 and 3, total of 7 cases are favorable. 7 ways are favorable out of the total of 25. So the required probability that we have is 7 favorable cases out of 25, which in percentage terms is 28%, right? Right. So therefore, bringing the flavor of overlapping ideas, right? Basics of probability and hardcore quadratic algebra question, actually, more or so, to understand or interpret that if it is given that fx is more than 0 always, that effectively means your discriminant is negative. All right, all right, all right. Right. So ready for the last problem for today's session? Saving the best for the last. Everything has been best, but a very interesting question coming your way. Maxima and minima in the style of averages. Now let's see who is fast. Okay, I'm taking this problem right away, and if you get this, do let me know. So effectively, it's a question of maxima and minima, because at the last it is asked, then at most how many marbles could one of the children who joined the group have? At most means maximization, right? So let's see. 5 children have an average of 6 marbles. 5 children, average of 6, 5 into 6, total 30 marbles. Very simple. So 1, 2, 3, 4, 5. These 5 children altogether, taken together, have a total of 30 of the marbles, right? Very nice. When 3 more children join them, 1, 2, 3. The average number of marbles with the 8 children matches with what it would have been if the child with the fewest marbles amongst the original 5 children had left the group. What? You might be thinking, what was just said over here? Now, carefully understand. 3 are people are joining. The average marbles are going to change. The original 5 children, we don't know their total number of marbles. These 3 children, how many marbles they have? Not known. The children who would hypothetically have left, who is having the lowest number of marbles, how many marbles did he have? Not known. So in any problem, when you say, oh, I did not get what it is all about, first identify the unknowns. There are 2 key unknowns. How many total marbles are there with these 3 children who are joining the group of 5 children? And how many marbles are there with the child having their fewest marbles amongst the original 5 children? Finish reading the problem. If all 8 children have distinct non-zero marbles, so there is no children who has 0 marbles, and no 2 children or more have the same number of marbles. Number of marbles with all the 8 children are distinct, and none of them have 0. Then you have to maximize the number of marbles with one of the children who joined the group. So you're trying to maximize the number of marbles with one of these 3 children. So obviously, the 2 variables which I have defined, you should take the problem further from there. Let's say that X is the total number of marbles with these 3 children. And let's say that amongst these 5 children, that Y denotes the lowest number of marbles amongst any of these 5 children. Now, for this statement, you would write the equation and then analyze it, and then think of the maximization, how to do that. So, right, I've set up the problem for you. You can try this problem and try to get to the answer faster than I reached there. Okay, CAT exams. I'll just check on that. I'll not reveal the answer as of now. Let's see. So when three more children join, the average number of marbles with the 8 children would be how much? Simply the total number of marbles, which is 30, plus x, the total number of marbles with the 8 children, divided by the number of children, which is 8. So this average number of marbles matches with, means it is equal to what it would have been if that child having y marbles had left. So if that child is leaving, we are now having a smaller group of 4 children who have 30 minus y marbles. So we can equate this average to the that that average of those 4 children, which is 30 minus y divided by 4. Agree? Agree. This is the equation that represents this statement. Once again, read the statement and look at the equation. When 3 more children join, the average number of marbles with the 8 children would be this much, 30 plus x by 8. So it matches with what it would have been if the child with the fewest marbles amongst the 5 children had left. So 30 minus y by 4. Now simplify this equation, you can get some relation between x and y, right? 4 cancels on either side, right? And you can cross multiply and you're getting, so 30 plus x equals twice of 30 minus y. So this is 60 minus 2y. So you're getting the relation that x plus twice of y, it comes over here, is 60 minus 30. So that is 30. So this is the equation which relates x and y. What is x? X is the total number of marbles with the 3 children who have joined the group. Y is the number of marbles with a child who has the lowest number of marbles. Nobody has 0 marbles. Everybody has distinct number of marbles. Now, obviously, it's a sum equation. If I have to, if I have to maximize the number of marbles with one of these 3 children, I have to maximize x first. First, the whole lot of x must be as high as possible, and from that, I would give the maximum to one child. So clearly, x must be maximized. So y must be minimized, obviously, but y can't be 0. So the absolutely least possible value of y is 1. So we would put our y as 1, the minimum possible value that it could be, right? So if y is 1, so now we are doing our optimization, right? Now we are deciding what values to put. This is question of maxima minima, in which you decide what values you will put for achieving the objective. So for the optimization purpose, for the maximization of the marbles with the child having the highest number of marbles, that is what you are asked. So for that, you will put y as 1. If y is 1, what is x? Then your x is what? 30 minus 2, which is 28. Now these 3 children over here have to be given, one of them has to be given the highest marbles. So the other 2 have to be given the least number of marbles. Now you have already given 1 marble to one of these 5 children. So you cannot give 1 marble to any of them. So the next least possibility that you can give is 2. And then the other person 3. So out of 28, 2 and 3, 5 is gone. So remaining 28 minus 5, which is 23, is the maximum that you can give to any child. That's your answer. Right. So this style of maxima minima questions have been asked in the setup of some constraint put in form of mean, even median, mode, statistical constraints, and doing the optimization. All right, so this was our session, people. All right, I'm very right. I'm very thrilled to be having discussed these problems with you and brought forward some new concepts, right? So no sad faces CAT exams, because we are learning new things, and that is what we are here for, right? The more we fail right now, the more we will get up and run fast in the actual exam, right? Abhi सीखेंगे तो आगे बढ़ेंगे. All right. So I'm looking forward for your comments and suggestions. Do let me know on the comment section what would you like to discuss, right? Because I'm bringing forward the topics as per my my own understanding, what is important, what is more relevant, what is new, right? So I'll be seeing you very soon once again, and stay in touch, stay connected, and do let me know. I'm looking forward to your suggestions, right? What we can discuss in the next sessions. Do let me know, right? All right. So this is me signing off. Thank you. Thank you so much. And yeah, thank you. All the best. All the best. 100 days. So keep it up. Keep fighting, right? Thank you.